All right, we're going to take a look at some balanced forces problems. So the first one we're going to take a look at is the skydiver's falling at terminal velocity, or a constant speed, of 50 meters per second. That's going really fast. And she has a mass of 50 kilograms. That comes out to about 120 pounds. So we're going to do several things. Sketch a system diagram to see which objects are interacting and what forces. Sketch a free body diagram in correct proportions. Sketch a vector addition diagram. Calculate the weight of the skydiver, the air resistance acting on her, and then we're going to figure out how far she fell in 10 seconds. And we're going to show that answer with algebra, and we're going to try to do that with a graph as well. So first, let's sketch a system diagram. So we've got our skydiver, obviously, and we got to think about what, oops, just one skydiver. We got to think about what's interacting with her. So obviously the Earth is pulling her down, and that is going to be a force of gravity there. So the Earth's pulling her down. And then it says that she's falling at a terminal velocity. So that means there has to be some opposing force. And in this case, she's been falling for long enough that the air resistance has built up enough. So the other one, we're just going to say air, you could say wind, etc. And this can be F friction. So air friction, we could have just said F air resistance. That's fine too. So we see here we just have two forces acting on our skydiver, one from the air and one from the Earth. So now we're going to sketch a free body diagram. So I'm going to represent the skydiver with a dot, and the Earth's pulling straight down on her. So there's our force of gravity. And we know, since there's a constant speed, that all of our forces have to be balanced. Okay, so sometimes it helps to jot down here, we recognize balanced forces. Remember, that's anytime we have a constant velocity, and that could be a constant velocity of 0 as well. So that means whatever force is pulling her down, there has to be one of equal size pushing or pulling up. And so in that case, that's air friction. And then we're going to sketch a vector addition diagram. We really don't need it here because this is such a simple problem and we can already see forces are balanced, but just for completeness, let's go ahead and do it. So I'm going to draw my force of gravity pointing down. And then when we add a vector to that one, remember we start at that tip and start the tail of the next vector there, and that one's pointing up. It's the same length, and so we see here we ended where we started, so that means that there's no resultant vector. All of our forces are balanced. That's usually just more helpful when we have a lot of different forces going on. In this case, you never really need to draw a vector addition diagram because it's so obvious that the forces are balanced. Next, let's calculate her weight. So remember, weight and force of gravity are the exact same thing, and that is measured in newtons, not pounds in this case. So weight and force of gravity can be measured in pounds in the English system, but here we're using metrics as newtons, and that is not mass, okay? So we have force of gravity, remember from our gravity versus mass lab, or force of gravity versus mass, that if we take the mass of an object in kilograms and multiply it by G, which is 10 newtons per kilogram, okay, or 0.01 newtons per gram, as you guys found in the lab, then that is going to give us the weight or the force of gravity. So her mass is 50 kilograms. We're going to multiply that by 10 newtons per kilogram, and that comes out to 500 newtons because the kilograms cancel out. Now we want to figure out the amount of air resistance acting on her. So it's important to recognize that all the forces are balanced, and that means all of the forces pointing up equal all of the forces pointing down. And so the air resistance, or air friction, is pointing up, and that equals all the forces pointing down, with is just the force of gravity. So we find out her air resistance is also 500 newtons. If you're answering this on a quiz or a test, make sure that you explicitly show that you know for air friction is equal to the force of gravity, and then put 500 newtons. Don't just put 500 newtons, you need to show how you knew that. All right, so now that we've figured out the weight and the air resistance, let's move on to how far she fell. So now we're relating this back to the constant velocity unit. And hopefully you remember the equation that we developed from our lab there. That is, the final position of an object is equal to the velocity of the object times the amount of time. and we add that to the initial position. If we're not really given an initial position, we just want to know how far something's moved, then we can always just call that 0, and that's perfectly fine. And we're going to do that in this case. So I want to know how far she fell, so that's going to be, I want to know what the final position is, assuming the initial 0, and we want to know how far she went in 10 seconds, and we know her velocity is 50 meters per second. Okay, so now let's go ahead and plug those numbers in. So we're trying to find XF, we're going to leave that there. And then our velocity is 50 meters per second. And we want to know how far she fell after 10 seconds. And we're going to call initial position 0. And we see we've got 500 meters. And seconds end up canceling. Got lots of 500s going on in this problem. Okay, so in 10 seconds, traveling at a constant speed of 50 meters per second, she's going to go 500 meters. Okay, so now let's see how we would solve this one graphically. So there's a couple different ways that we could go ahead and do that. So let's take a look. So we want to know how far. So we could do a position versus time graph or a velocity versus time graph. So I'll just start with a position versus time graph. So we're going to have X on the y-axis, T on the x-axis. We're going to start here at 0. So we're just going to say she's starting here at 0. And we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and for this one, we need to start plotting on her graph. Well, her speed is 50 meters per second. So that means that the slope of the graph is equal to 50 meters per second. Okay, so when I'm plotting out what's on the x-axis, just to get some nice round numbers here, I might make each of these lines 50. Oops, and I'm going to be running out of room here. So if that happens, no worries, just go ahead and erase. Okay, this can happen to you guys too, that's okay. Okay, and then let's start down here a little bit. Because remember, we do not want to be going off of the grid paper. That is not allowed, even when you're the teacher. So then you got to fix your mistakes. Okay, so I'm going to make that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to make each of these lines 50 meters. So I'm going to alternate them, go 100, 200, 300, 400, and 500. So if the slope is 50 meters per second, then that means we're going to go up 50 for every second we go over. Okay, so up 50 over 1 second, up 50 over 1 second, and so on and so forth. Okay, until I've got enough dots, I can draw a line. Okay, and again, remember that you guys want to use grid paper and a ruler for this, so to draw the best fit line. And so I want to know where she's at 10 seconds. So I'm going to follow up from 10 seconds to here, follow that over, and then we see she's at 500 meters. That's one way to do it. To me, that's a little trickier because then you're trying to plot the slope on here rather than knowing what's on the x and the y axis. So I'm going to try this again, but I am going to do a velocity graph this time. Okay, so we're going to call this V meters per second. And I'm going to count, what do we want to do here? So she's got a velocity of 50 meters. So let's say this 10, 20, 30, 40, 50. So I'm going to make each of these 10 meters per second. And she's just going to have that constant velocity. So she's going to have a nice constant flat line there. And we're looking at 10 seconds. And we want to know how far she went from 0 to 10 seconds. So remember, if we find the area in the V versus T graph, that is going to equal her displacement, or basically how far did she go. Okay, compare where she started to where she ended. So the area of a box is base times height. So the base here is 10 seconds. The height is 50. This is velocity, so that's meters per second. So that equals 500 meters. So this says she traveled 500 meters. So one question, 3 different solutions to solve it. 1 using algebra and 2 using graphs. Hopefully that made sense, and if you have any questions, of course, always send me an email or let me know in person.